Welcome to Episode 3 on AI agents. This is the most exciting and fastest growing area in the AI-103 exam. Agents represent a fundamental shift in how we build AI systems. Instead of a model answering one question, an agent can take a goal, decide which tools to use, call those tools, evaluate the results, and continue until it achieves the objective. In this episode, we will cover the Microsoft Foundry Agent Service, the tools agents can use, how to build and run agents in code, multi-agent orchestration patterns, and the developer frameworks Semantic Kernel and AutoGen. We will also cover the critical exam trap of when to use agents versus prompt flow. Let us start with the fundamentals. An AI agent is a system that can take a sequence of actions to achieve a goal. The difference from a simple chat completion is fundamental. With a chat completion, you send a message and get an answer. That is it. With an agent, you give it a goal and it figures out what steps to take. The agent perceives its current state. What did the user ask? What tools are available? What has already been tried? It reasons about the best next action. It acts by calling a tool, executing code, or generating text. It evaluates the result and decides whether the goal is achieved or more steps are needed. This loop continues until the task is done. The anatomy of an agent in the Foundry Agent Service has 4 components. Instructions define who the agent is and how it should behave. Tools are the capabilities the agent can invoke, like code execution or file search. A thread is the conversation history between the agent and a user. A run is a single execution of the agent on a given thread. The Microsoft Foundry Agent Service is the fully managed platform for building agents on Azure. Previously called Azure AI Agent Service, it handles all the infrastructure for you: state management, tool orchestration, execution, and logging. There are 4 built-in tools you need to memorize for the exam. Code Interpreter executes Python code in a sandboxed container. You can upload files, and the agent can write and run code to analyze them. File Search performs vector search over documents you upload to the agent. It automatically chunks, embeds, and indexes your files. Bing Grounding connects your agent to the live web so it can retrieve current information. Azure AI Search connects the agent to your enterprise search index for domain-specific RAG. Beyond built-in tools, you can define custom function tools using JSON schemas. The agent decides when to call your function. You receive the call parameters and return the result back to the agent's context. This enables integration with any system, databases, CRMs, payment processors, anything. Here's the code for creating and running an agent in the Foundry Agent Service. You import AI Project Client and authenticate with managed identity via default Azure credential. You create an agent by specifying a model, a name, system instructions, and an array of tools. In this example, the agent has Bing Grounding for real-time web search and code, Interpreter for executing Python code. You then create a thread, which is the conversation session. You add a message to that thread from the user. Finally, Create and Process Run starts the agent and waits for it to complete. The agent will internally decide, do I need to search the web, write code, do both? It executes the necessary steps, and the final message in the thread is its answer. The exam may ask you, which of these methods starts an agent run and waits for completion? The answer is Create and Process Run. If you use Create Run without process, you need to poll the run status yourself until it reaches completed or failed. Understanding the thread message run model is essential for both coding questions and case study questions. A thread is the persistent conversation container. Think of it like a chat session. All messages between the user and the agent are stored in the thread. This gives the agent memory of the conversation across multiple turns. A message is a single piece of content added to the thread. Messages have roles: user for human input and assistant for agent output. A run is triggered when you ask the agent to process the current thread state. During a run, the agent reads all messages, decides on actions, and executes them. Run statuses matter for exam questions. Queued means waiting to start. In progress means actively executing. Requires action means the agent called a function tool and is waiting for your code to provide the result. Completed means success. Failed means an error occurred. Run steps are the individual actions within a run. A tool call step records the agent invoking a tool and receiving results. A message creation step records the agent writing a response. You can inspect run steps to understand exactly what the agent did and why. Custom function tools are how you connect agents to your own systems and data. The workflow has 4 steps. First, you define the tool as a JSON schema describing its name, what it does, and what parameters it accepts. Second, the agent's underlying language model reads these schemas and decides when to call each tool based on the descriptions you wrote. Third, when the agent decides to call a function, the run enters the requires action status. The run is paused, and you receive the function name and arguments the agent wants to use. Fourth, your application code executes the actual function with those arguments, then submits the result back to the run. The agent continues from there. The quality of your tool descriptions directly affects how well the agent uses them. Write clear, specific descriptions. If a description is vague, the agent may call the wrong tool or not call it when it should. On the security side, always validate parameters before executing any function. Agents can sometimes be manipulated via prompt injection in the user's input, so never trust function parameters without validation. Semantic Kernel is Microsoft's open-source developer framework for building AI agents. It is available in Python, C#, and Java, and it abstracts away the complexity of orchestrating language model calls, tool invocations, and agent reasoning loops. The core concepts. The kernel is the central object you build around. You add AI services, like your Azure OpenAI connection, and plugins, collections of functions to it. Plugins are the semantic kernel equivalent of tools. They are just Python or C# functions decorated with a description attribute that the model reads. The planner component can automatically figure out which functions to call in what sequence to achieve a given goal, without you explicitly coding the workflow. Memory connects to vector stores like Azure AI Search, giving the agent access to long-term context beyond the current conversation. When should you use Semantic Kernel versus the Foundry Agent Service? Use Semantic Kernel when you need fine-grained control, want to write complex agent logic and code, or are integrating deeply with an existing Python or .NET application. Use Foundry Agent Service when you want a managed, hosted, serverless approach with built-in tools that require no infrastructure management. Here is a semantic kernel example you might see in a code review question. We define a plugin class called Weather Plugin with a method decorated with @kernel function. The description attribute is critical. The language model reads this description to decide when to call this function. We then build a kernel object and add our Azure OpenAI service to it. We add the plugin so the kernel knows what tools are available. When we invoke a prompt with function choice behavior set to auto, the kernel enables the language model to call the weather function automatically when relevant. The model decides to call getWeather with Seattle as the city, the function runs, and the result is incorporated into the model's final response. For the exam, watch for questions about what makes a plugin function callable by the model. The answer is always the kernel function decorator and its description attribute. If the description is missing or unclear, the model will not know when to call the function. AutoGen is Microsoft's open-source framework for multi-agent systems where agents collaborate by talking to each other. The core pattern: you create multiple agents with different roles, and they exchange messages to accomplish a task together. The two most common agent types are assistant agent and user proxy agent. The assistant agent is powered by an LLM and can use tools and generate responses. The user proxy agent represents the human user, executes code in a local environment, and can require human approval before proceeding. In a two-agent setup, the user proxy sends a task to the assistant writes code to solve it, the user proxy executes that code, returns the output to the assistant for evaluation, and this loop continues until the task is done. Group chat patterns add multiple specialists. For example, a coder agent writes code, a reviewer agent critiques it, and a documentation agent writes the docs. For the exam, AutoGen is specifically for multi-agent conversational systems. If a question asks about agents collaborating, debating, or reviewing each other's work, AutoGen is the answer. If a question asks about a single agent with tools, Foundry Agent Service or Semantic Kernel is the answer. This two-way comparison is tested heavily in the exam. Let us make it crystal clear. Use prompt flow when the workflow steps are predetermined. You know it will always extract keywords, then search the database, then rank results, then summarize. The sequence never changes. Prompt flow is perfect for this. It is also the right choice for batch processing, running a large dataset through an AI pipeline, and for evaluation, measuring the quality of AI outputs against a test set. Prompt flow generates deployable API endpoints from your flow, making it easy to productionize. Use agents when the goal is clear, but the path to get there is not. The agent decides at runtime which tools to use, how many times to call them, and in what order based on what it learns from each step. A user asking analyze my sales data and tell me what is unusual requires an agent. The agent might read the data, write code to calculate statistics, search for industry benchmarks, and format a report, but the exact sequence depends on what it finds. The exam will give you scenarios and ask which approach fits. Always ask yourself, is the sequence of steps known in advance? If yes, prompt flow. If no, agents. Multi-agent architectures allow you to break complex tasks into specialized components. Think of it like hiring a team instead of one generalist. The sequential pattern chains agents. The first agent extracts requirements, passes them to a researcher agent, which passes findings to a writer agent. Fan-out sends the same task to multiple specialist agents simultaneously. For example, send a business question to a market analyst agent, a financial analyst agent, and a risk analyst agent at the same time, then combine their perspectives. Fan-in collects the results from multiple sources and synthesizes them into a final answer. This is often used after a fan-out pattern. The handoff pattern allows one agent to recognize it lacks the expertise for a task and transfer the conversation to a more appropriate specialist. The orchestrator pattern is the most important for the exam. A top-level orchestrator agent receives the user's goal and breaks it into subtasks. Each subtask goes to a specialized worker agent. The orchestrator collects results and produces the final response. This architecture is testable and traceable because each agent's work is isolated and logged. Let us nail down the Episode 3 exam traps. Trap 1 is the prompt flow versus agents distinction we just covered. Predetermined steps go to prompt flow. Dynamic, goal-seeking tasks go to agents. Trap 2. Foundry Agent Service versus Semantic Kernel. These are complementary, not competing. Foundry Agent Service is a fully managed, hosted service. Semantic Kernel is a code framework for building custom agent orchestration logic. You can use Semantic Kernel as the brains behind your Foundry Agent Service deployment. Trap 3. The requires action status. When a run enters requires action, the agent has decided to call a custom function tool and is pausing to let your code execute that function and return the result. This is not an error state. It is the expected behavior for function tool calling. If you see a run stuck in requires action, check whether your code is properly submitting tool outputs back. Trap 4. AutoGen versus single agent. AutoGen adds communication between agents. If the scenario describes one agent doing a task, AutoGen is overkill. AutoGen shines when multiple agents need to collaborate, debate, or review each other's work. Agents need memory to maintain context across a long conversation or a complex task. There are 3 types of memory you need to understand. In-context memory is the thread history. Everything in the thread is available to the agent, but this is limited by the model's context window. A very long conversation will eventually exceed the limit. External memory uses a vector store for semantic retrieval. When the agent needs information that is not in the current thread, it can search an external knowledge base. The file search built-in tool is essentially pre-configured external memory. You upload your documents and the agent automatically retrieves relevant sections when needed. Structured memory uses traditional databases or key-value stores for facts and state. For example, the user's preferences, account information, or the results of a previous session. For the exam, if a question asks how to give an agent access to company documentation, the answer is File Search Tool or Azure AI Search Integration. If a question asks about handling very long conversations, the answer is Summarization, or using external memory instead of relying only on the thread. Bing grounding is the built-in tool that connects your agent to live web search. When enabled, the agent can search Bing whenever it determines current information is needed. This is critical for use cases where the model's training data is outdated, current events, recent product releases, live pricing, or breaking news. To use Bing grounding, you need a Bing search resource in your Azure subscription, and you connect it to your agent in the Foundry portal or via API. The agent automatically includes source URLs in its responses, providing citations. Know when not to use Bing grounding. For internal document Q&A, where all relevant information is already in your own files, Azure AI Search is the better choice. It is faster, more secure, and cheaper. For highly regulated industries like healthcare or finance, using public web results may violate compliance requirements around data provenance. For the exam, the key distinction is internal knowledge versus external, real-time knowledge. Internal, Azure AI Search. External and current, Bing grounding. Let us lock in Episode 3. Agents are AI systems that pursue goals through a perceive, reason, act loop. Unlike single chat completions, agents can execute multiple steps, call multiple tools, and adapt their approach based on what they learn. The Foundry Agent Service provides the managed infrastructure. Remember the 4 built-in tools: Code Interpreter, File Search, Bing Grounding, and Azure AI Search. Threads hold conversation history. Runs are executions. Run steps track every action the agent took. When a run enters requires action, your code must submit the function tool results back, otherwise the run times out and fails. The biggest exam trap: prompt flow versus agents. If the sequence of steps is known in advance, use prompt flow. If the agent needs to decide at runtime, use agents. Semantic Kernel is for developers who want fine-grained code control. AutoGen is for multi-agent collaboration where agents talk to each other. In Episode 4, we covered Domain 1, planning, managing, and securing AI solutions. This includes the hub and project architecture in depth, RBAC, identity, and responsible AI. See you there.